Welcome back to the channel. So my wife is traveling, and I think this gives me the right time to do the beginning of my NIR in the home project. That is, I want to use a portable infrared spectrometer like this to analyze a bunch of chemicals in the home like this. And the benefit is when we look at these types of plastics, they oftentimes come with the label already. So I know that this is a plastic number 2. It is high density polyethylene. And many of these other containers are also labeled with the plastic type that was used to comprise and mold these products. And so that's what we're going to do. We're going to focus on not only the measurement piece, but also how we collect the metadata associated with that. And so what we need is a sample ID to link the metadata, the data about the materials themselves that helps us describe it, and the analytical data that we're collecting with this spectrometer. And so what I'm showing you now is the table we're going to use where we have a sample ID, and that will be the shared key. And then material description, in this case for this video, is going to be plastic containers. We're going to have a plastic type and a primary color field. I'm not sure if these are all the fields we want to collect, but this is what we'll start off with. So what I'll begin to do is collect this data and record the necessary metadata for several plastics that I have down here. And at the end of the video, I will show you what all those plastics look like. And in a separate video, we'll analyze that in the context of this metadata. So I've already got this device fully calibrated. And what I would begin to do is collect the information on this container. So as I've already mentioned before, this is a plastic container. It's high density polyethylene. And so I will call this sample 1. And the material description is plastic container. The plastic type is HDPE, and the primary color is white. So this matters. I believe the primary color probably matters in case we have any sort of scattering or other effects that will be impacted by the color of the material. For instance, black versus opaque could really matter and give an odd result. So we're going to collect that. And on the experiment side, we're just going to put in sample ID 1. And that's all we're going to need to link this sample ID 1 here to the sample ID 1 that can be found in that table I've just shown you. And now I will collect that data. So go to measure sample, and I will just collect a few replicates around the white sides of this material. And so that's 3 measurements on this material, and they all look pretty good. So let me show you. And here we can see that for the most part, we have really good absorbance consistency here, a little bit more scatter out here, but I think that's fine. And the one that was off is when I was measuring the back, and I think it's due to the concavity of it, just getting a nice contact. But that's how we collect replicates. I actually want this variation in the data. And let's move to the next container. So this is also HDPE. We're just going to call this 2. And just call this plastic container HDPE, and say the primary color is white. So let's do the same thing. I'm going to go into here and make a new sample. So sample ID 2, go to measure sample, and to do this all over again, I'll collect a few measurements along the sides of the container. It's really fast. And as you can imagine, these should look pretty similar, considering that this is also HDPE. And if we see a quick look at that data, again, very consistent. I won't show you the data for everything until the very end, but I at least want you to see where we're beginning. And let me now switch to another sample. And we'll call this sample 3, plastic container. The material type is also HDPE, and it's blue. So what I will do is measure this again and try to pick this with Cyrac if I can get a nice good contact with the surface, and also avoid any of the artwork that's on these containers. So if we look at this data here, we can see that again, it does look very similar to the other HDPEs. We do see a little bit more variation between the samples, and that's probably not surprising considering it was hard to get a nice flat surface to measure on. But again, the type of variation we want to understand, and likely can be corrected with signal processing that we've discussed before. So now I'll go a little bit faster. I'll look at a lot more samples, and then we'll show you what that it looks like towards the end. So here we have polypropylene, and we'll take a few measurements like we did before. And just like that, we're ready to recycle it. Got another container. This is polyethylene. So let me mark that. And we have polypropylene, and we'll keep going. Whoops. Little mess. Desk a little cleaner. You've got another PETE. So we also have some things that could pose for an interesting observation here. So we have a black container. It is recycle number 3, which is polyvinyl chloride. So let's record that. So definitely not a food grade plastic. And the fact that it's black could pose challenges for a device that relies a lot on optics, as black will absorb. So we'll still collect that data, but let me also update the app. So now we're on sample 14, and let's collect. And we look at the data, we're definitely just really absorbing all the light, which is not surprising for black material, but definitely worth noting. And that's why, as part of our metadata, we will keep track of the color, because there could be other PVC containers where it is not black, and we will have a more responsive signal, but good for this analysis in the home. And so, as I promised, let's now look at all this data, which should be in the cloud by now. And in the NIR in the home data set, we have 44 measurements, 14 samples, which is in agreement with our data table here. And we have a lot of data to look at. So again, these are likely those black samples, that polyvinyl chloride. And we see we have a couple of distinct patterns, maybe some shifts. And so it'd be really cool to see what signal processing and the additional metadata context can tell us about the types of plastic, maybe the color, and how that might contribute to the patterns that we see here. But also, we start adding some different material classes all together and how those separate in the multidimensional domain, like pharmaceutical compounds, lotions, oils, conditioners, shampoos, which we'll be doing in future videos. And if you want to be notified when that comes out, subscribe to the channel. I'll see you in the next one. Peace.